Hi everyone, today we are going to talk about drawing atoms and dot diagrams. So the rest of this week we're going to be working on researching an atom, which it also involves like being able to draw our model of the atom. So we need to learn how to do that. So our essential question for today is, how do we create models of an atom? So as we're going through this, just pause it wherever you need to and fill in your notes, because these should be Cornell notes. You should also be using the note-taking handout for today that is by the door. All right, so this is just a review, nothing to write down on this slide. We have a model of the atom over here, right? And so we've talked about the nucleus and the protons and the neutrons being in there. And we've talked about the electron cloud out here, where the electrons go. But when we're drawing a model, how do we know where to put the electrons? So that's what we're going to talk about today. All right, so we have these things called energy levels, and that's where the electrons are going to go, but each energy level can hold a specific number of electrons. So the energy level closest to the nucleus is what we're going to fill first, and we label that n equals 1 for energy level 1. All right, so certain numbers of electrons can fit into each energy level. This I want you to add into your notes, okay? So pause it wherever you need to and add this in. You can draw this diagram. Right? This is the nucleus in the center. The first ring around the nucleus is going to be the first energy level. It can only hold 2 electrons, right? That totally makes sense because it's smaller than the rest of the energy levels. Small spaces can hold less things. The second energy level can hold up to 8 electrons. And the third energy level can hold up to 18, but this is where things get a little bit complicated because we can put 8 electrons in here. And once we get 8 electrons in here, we jump up to the next energy level and put 8 here. Then we jump back to the fourth one to finish filling it up to get to the 18, okay? You don't really need to worry about that. We're not going to be drawing any models of atoms where we're going to run into this, because we're really only going to be drawing things up to the third energy level. All right, but when you get to chemistry, this is something that you'll have to kind of think back on and be able to do. All right, so here we have an atom of lithium, and we're going to draw the Bohr model for this. And so for all of the atoms that we're going to draw off of the periodic table, we're going to use the most common isotope. So down here, lithium we see has an average atomic mass of 6.94, which means the most common isotope is going to be lithium-7. All right, so that is what we're going to draw. So reminder, we need to be able to know how many protons, how many neutrons, and how many electrons from this information in order to be able to draw the Bohr model, right? So here's a refresher, a reminder on how to do that. All right, so the protons are going to be the number up here at the top. This is the atomic number, right? So we're going to have 3 protons, and then I'm going to put that in the center. I can either draw 3 protons in the middle, but for the bigger atoms, it just makes sense to write the number of protons. All right, and then for neutrons, remember this mass up here comes from protons and neutrons, so we have to subtract the protons from it. So neutrons is going to be 7 minus 3. That gives us 4 neutrons. Okay, so now I have my nucleus. Now I need to be able to do the electron part, which is the new part. All right, so electrons has to be same as protons because this is a neutral atom. We have to have the same amount of positive and negative. So now I'm going to put those in the correct order. Remember, the first energy level here can only hold 2. So we're going to put the first 2 electrons in. We still have 1 more to add, so we're going to jump up to the next level. All right, so there's my Bohr model for lithium. All right, so we're going to be working on our note-taking handout to do some Bohr models. I'm going to do some more examples for you. All right, in your note-taking handout, you guys have a really small condensed version of a periodic table because we're only going to be doing the first 3 periods. So I've given you a periodic table that basically only has, let's see, this part. Okay, and so the periodic tables you have for practice today have left all the rest of this out. All right, and so you can see you've got one that looks kind of like this. And so you can kind of see where that shape comes from, right? So this right here is kind of the separator line. This is going to be our 1A, and I think I labeled this on your periodic tables already. So this is our 1A column or group 2A. And then remember how we talked about the A and the B group, how we can kind of skip over these, and when we jump over to here, this is 3A, 4A, etc. until we get up to 8A. So this is going to be our 3A, 4A, 5A, 6A, 7A, and our noble gases, our 8A. All right, so that's what we're going to be doing with these charts today. All right, so you do have on your note-taking handout some instructions for these. All right, it explains how to fill in your Bohr models. You've actually been given all of the possible electrons for these Bohr models, and you're going to fill in the ones that you need, okay? So all of these dots are spaces that are available for electrons. All right, let's look at a few more examples though. Okay, so this one right here is basically what you're going to see for anything in the first period, right? In the first period. So remember, the first period is only hydrogen and helium, right? So this kind of makes sense also why we see any atoms, if this is the nucleus, with the first energy level, right? It can only hold 2 electrons. And look it, there's only 2 atoms in the first period, right? So hydrogen would have 1 electron out there, helium would have 2, and its outer energy level would be full. Oop, I smudged that, right? And so what we see is that actually energy levels correspond to the period. So we're only going to have 1 energy level for period 1, okay? So if this is my nucleus, I would have 1 energy level for both of those atoms, all right? For period 2, I would have 2 energy levels, right? If that's my nucleus, I'd have an atom that had 2 energy levels in the electron cloud. And then for these ones, I would have 3, right? And that's what you're going to see in your handout today. All right, and that pattern continues all the way down till finally we get to the 7th period, and there are 7 of those energy levels. Okay, so this one could be for hydrogen or it could be for helium. Okay, this example has a nucleus where I could put my protons and I could put my neutrons. And then I've got energy level 1, and I've got energy level 2. And so this must be for a period 2 element, okay? I could use this to fill in any of them. And by the way, any period 2 element, like these first ones need to be full, right? Because you have to fill up the inside ones first, at least until you get up to period 4. Okay, and so same thing here. If this is my nucleus, this must be for a period 3 element because we have 1, 2, 3 energy levels, and I would just fill in the electrons that I need. So let's pick one to do. All right, for example, let's pick phosphorus. Okay, so phosphorus has, we go over here, 15 protons, right, because the atomic number is 15. And the most common isotope of phosphorus is going to be phosphorus 31, right? So if I come up here and say phosphorus 31 is what I'm going to do. That means for my neutrons, I need to take 31 minus 15, so that gives me 16 neutrons. So I can go to my nucleus and do this. 15 protons, 16 neutrons. Okay? Oh, I should have done this too. All right, so dealing with neutral atoms, the charge is going to be 0, right? Overall charge is 0. That means I have to have the same number of protons and electrons because these are positive and these are negative, right? So now I have to come in here and I have to fill in 15 electrons. So I have to start on the inside. So I would fill in 1, 2, and then I go to the next energy level. 3, 4, 5, 6, 7, 8, 9, 10. So I have 5 more to go, right? I've got 10 filled in so far. 11, 12, 13, 14, 15. Okay, notice what I did on this outside energy level. I kind of left the unfilled ones spaced out a little bit. That's because electrons repel each other, and so any holes that you're going to find are kind of spaced out in real life. Okay, so you're not going to get it wrong if you don't do this, but I just do that because that kind of reflects real life a little bit more. All right, so you guys are going to be working on this one right here, and you already have a periodic table you can use. You can use the periodic table that is taped into your notebook from last week to find the number of protons and the number of neutrons. Again, when you're finding the number of neutrons, just look at your atomic mass here, okay? So remember, round this to a whole number. So for the number of neutrons, let's put these instructions up here. For number of neutrons, round the mass to a whole number and subtract the protons, or the number of protons. Okay, so pause this, and I'm going to have you guys draw out all of your Bohr model diagrams for the first 18 elements. Remember, we did phosphorus together already, and that's going to be right here, right? Also, let's label all of these. So let's take a second to, actually, I'll help you with the masses here. Okay, we'll write the element symbol and the mass number for each, okay? So hydrogen, we're going to do hydrogen 1, right? This is the isotope name, so 1 is the mass number. And helium is 4. All right, and then we're going to have lithium. Let's see. So you guys should be following along and adding this onto your periodic table that you have for your note-taking handout. Beryllium 9. boron 11, carbon 12. So we'll use these to find our neutrons, right? And nitrogen 14, oxygen 16. So these are all the most common isotopes, just rounding the mass number to a whole number. Fluorine 19, neon 20, going down to the third period now. We have sodium 23, magnesium 24, aluminum 27. So remember, this is where we skip over all the transition metals, or we jump over to 3A. All right, so this is aluminum 27, silicon 28, and then this is the one we did together just now, phosphorus 31, sulfur 32, chlorine 35, and argon 40. Okay, so now you have the mass numbers for each of these to use to find those number of neutrons. Okay, all right, so pause this, do this, and then I think I had this relabeled observations. Try to find two patterns, okay? So two patterns. What is the same going down? What is the pattern going across? And write that at the bottom. All right, this should take you about 10 to 15 minutes to complete, and then finish the video. We'll do the dot portion. All right, so then we have these things called electron dot diagrams. Add this to your Cornell notes, right? This is a definition. The electron dot diagrams include the element symbol and then only the valence electrons as dots. So the valence electrons are those electrons on the very outside energy level that you were drawing. All right, so here's a Bohr model. This would be, let's see, 17. So this is chlorine, okay? For the dot diagram, we would only include the element symbol and then the 7 electrons that are in the outside energy level. So this is what the electron dot diagram would look like. All right, so let's look at a couple examples. You do not have to put the examples in your notes because you'll have the practice in the handout. All right, so normally when we did the Bohr model for oxygen, you can check your oxygen, by the way, because this is what it should look like, except for your electrons will be spaced out more. All right, so we have electrons out here, protons and neutrons in the center. But the electrons on the outside, so these ones on the outside energy level, are the ones that are involved in chemical reactions. They're the ones that are involved in reactivity, okay? And they're the ones that give the element its physical and chemical properties. So that's why we're kind of interested in just drawing the dot diagrams. To draw a dot diagram, we write the element symbol, and then we put those outer valence electrons around it. Okay, so add these instructions to your notes. And you can put this one example in your notes if you want to. We're writing the element symbol, and then we're going to place these dots around it. So the dots have to go first one at a time. So 1, 2, 3, 4. We pretend that there's 4 sides to the element, like it's inside a square box, okay? And then we go around and we add any other electrons. So we need a total of 2, 4, 5, 6. I only have 4 right now, so I'm going to add in 5 and 6. So this is the electron dot diagram for oxygen. So we can do the electron dot diagrams for any A group element really, really easily, because remember that group number tells us what the valence electrons are. So we don't even have to do the Bohr model. right? All we have to look at is to see which A group it is in. What is the group number? And then that's how many dots should go around it. So the A group number equals valence electrons. Add this to your notes. All right, so the valence electrons are the number of dots in your diagram. All right, so remember these are the A group elements. Okay, so we have 1, 2, skip a few, 3, 4, 5, 6, 7, 8, right? So these are the A group. And this is exactly how many dots or how many valence electrons you will have for these elements. Okay, so there is one exception, right? And you should know this exception now after drawing those Bohr models. Helium is the only atom that can only hold 2 in its valence shell. So notice this is an 8A, so we would think that anything in this column should have 8 dots around it, but not helium. It's literally the only atom on the periodic table that is an exception to this pattern or this rule, okay? So jot that down. Helium will have only 2 electrons in its outer shell, even though it's in group 8A. All right, so we're going to do another example here and do aluminum, which is element number 13. Right, so step 1 is to just write your element symbol. Step 2 is to say, hey, this is, in terms of A group elements, this is actually 3A, so it has to have 3 valence electrons. So I'm going to put 3 dots around it. 1, 2, 3, and I'm done. Okay, so electron dot diagrams are fast and easy. Let's look at sodium. Right, sodium's over here, so step 1 is the element symbol. Step 2 is the dots. So I'm in group 1A, so I just need 1 dot. All right, and that 1 dot can go on any of the sides. All right, it doesn't really matter where you start with your dots as long as you do one at a time and then pair them up. All right, and last one is sulfur. So right here, atomic number 16. We'll put the symbol and then we'll add those dots. So it's in group 16, which is the same as 6A. So we need 6 dots. 1, 2, 3, 4, 5, 6. Okay? All right, so you have a summary of how to do these dot diagrams in the front of your handout. I've already described it, but if you need to reread the instructions or summary, they're there for you. All right, so again, this is your dot diagram portion of your handout in practice. So if you didn't already, label these 1A, 2A. Remember, we skip the transition metals. 3A, 4A. 6A, 7A, and 8A. All right. And I know your printouts came out so that you don't really have any room over here, but this is period 1, period 2, and period 3. All right, and then we're going to write the element symbols for each of these in here. All right, so this is hydrogen, this is helium, and we have lithium and beryllium. And then skipping the transition metal area, boron, carbon, nitrogen, oxygen, fluorine, and neon. All right, and the third period, we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Okay, so now you have the element symbols, and now you're going to practice drawing the dots. Remember, a few of these we already did together, right? So I think sulfur was one of those that we did together in the notes. It was 6A, so 1, 2, 3, 4, and then back around to do 6 dots. All right, and then what was another one that we did? Aluminum we did, it was in the 3A group. So again, remember, you can start anywhere you want. So let me start at the bottom this time. 1, 2, 3. Okay. And so you're going to do all of your dot diagrams just like that. When you are done for today, take a picture of your notes. Oh, I forgot. You're supposed to do 2 observations here too. So for your observations, make an observation about the patterns going across. And you can also think back to your periodic aliens on this, right? So the patterns going across, and then any similarities down, all right? And so write those 2 observations here, then finish your summary for your Cornell notes. Take the picture of your Cornell notes, take a picture of your handout work, and turn it in on Canvas. Okay, so you should be able to finish this by the end of class. If not, otherwise finish it and get it turned in as homework. All right, I'll see you all on your block day. Have a good day.